Okay, for this problem here, we want to evaluate this radical given that x is equal to -6, y equals 5, and z equals 4. So all we're going to do is we're going to substitute those x, y, and z values into this radical. And actually, it looks like we're not using the y in number 5 here, so I don't even need to worry about that. So let's see, if substituting in -6 for x gives me -6 squared, since I'm squaring my x, times 4 for z plus -6 times z, which is 4 squared. Now notice my use of parentheses here. I really advocate for parentheses. That way you're not going to mix up any negative signs, and you know that you're still multiplying everything through without having to write the actual multiplication symbol in there. So use those parentheses. Okay, so from here on out, we're using PEMDAS on the inside of this thing. So my first step, I'm going to square this -6, and -6 times -6 is positive 36 times 4 plus -6 times 16. So first I square this 4 before doing the multiplication here. And let's see, this is going to equal, this is 144. And then I'm going to have a minus sign since I have a negative times a positive here. So it's going to turn this into subtraction, and I'm subtracting, that is 96. And one more row down here, when I take the square root of all this, looks like I have the square root of 48. And I'm not done here. So I've simplified everything inside the radical, but now I need to actually simplify the radical itself. So for this, let's switch to red. Again, I want to split this up into the largest perfect square factor that I can. And 48 splits nicely into 16 and 3. And this is going to equal 4 root 3. There you go.